Hello guys, welcome aboard Apex Math. My name is Meno. In this video, we go through question 6 from the August 2025 and 5 mathematics question paper. Question 6.1, we determine the general solution of this first order differential equation. The first step is for us to have that dy on the left hand side. So on the left hand side, we'll have the dy and we'll multiply both sides of the equation so that on the right hand side we have that dx. So we'll move that dx to the right hand side, and on the left hand side we'll have that dy with all the functions of y. The function of y that we have is the 2y cubed minus y and the y to the power 5. So we'll move all the functions of y to the left hand side. So on the left hand side we'll have the dy with all the functions of y, and the functions of x, the x minus 1 and the x squared, will remain on the right hand side. So on the right hand side we have all the functions of x with the dx. Later we will introduce the integral both sides of the equation, and on the left hand side we will integrate with respect to y, and on the right hand side we integrate with respect to the x. Alright, so let's start off by multiplying both sides of the equation by dx so that we move the dx to the right, and on the left hand side that dx will cancel out with that dx and we'll be left with the dy, and it will be equal the x minus 1 multiplied by y to the power 5 all divided by x squared multiplied by 2y cubed minus y, and we have our dx. So let's move the functions of y to the left so that they can join with the dy. So we'll multiply both sides of the equation by 2y cubed minus y divided by y to the power 5, and what we do on the right we also do on the left. So we multiply the left by 2y cubed minus y divided by y to the power 5. On the right hand side, that 2y cubed minus y will cancel out, and the y to the power 5 will also cancel out, such that we'll be left with 2y cubed minus y multiplied by the dy on the left divided by y to the power 5, and on the right hand side we'll be left with the x minus 1 divided by the x squared multiplied by dx. So we have the functions of y with the dy on the left and the functions of x with the dx on the left, on the right I meant. Suppose that we had a minus b divided by c. This will be equal a divided by c minus b divided by c. So that 2y cubed will be divided by y to the power 5. That y will also be divided by y to the power 5. The x will be divided by the x squared. The negative 1 will be divided by the x squared. So we have 2y cubed divided by y to the power 5 minus y divided by y to the power 5 dy, and this will be equal the x divided by x squared minus 1 divided by x squared multiplied by the dx. On the left hand side we have the 2y cubed divided by y to the power 5. So since the bases are the same, we can just minus the exponent since we are dividing. So we'll minus by that 5 minus y to the power 1, so that y is raised to the power 1. The bases are the same, we minus with that 5. The exponents are minusing. dy, this will be equal x divided by x squared will be equal 1 divided by x minus 1 divided by x squared dx. So we simplify before we can introduce the integral. So we have the 2 multiplied by y raised to the power 3 minus 5 is equal to minus 2 minus y raised to the power 1 minus 5 is equal to minus 4 dy, and this will be equal 1 divided by x. We move that x squared from the denominator to the numerator, and its exponent will change sign to negative 2 dx. So now we can introduce the integral both sides of the equation. On the left hand side, we integrate with respect to y, and on the right, we integrate with respect to x. So let's integrate the left. We have 2 multiplied by the integral of y to the power negative 2, which is just y to the power negative 2, but we add 1 to its exponent, and we divide by the new exponent, the negative 2 plus 1. Remember, when we differentiated, we multiplied. Now we integrate, we divide, minus the integral of y to the power negative 4, which is y to the power negative 4. We add 1 to the exponent, we divide by the new exponent, the negative 4 plus 1. This will be equal, on the left hand side we integrated with respect to y, on the right we integrate with respect to x. So the integral of 1 over x will be the ln x, minus the integral of x to the power negative 2, which will be x to the power negative 2. We add 1 to the exponent, and we divide by our new exponent, the negative 2 plus 1, plus our constant c. We simplify, and we have 2 multiplied by y raised to the power negative 2 plus 1, which is equal to negative 1. Negative 2 plus 1 in the denominator will be equal to negative 1, minus y raised to the power negative 4 plus 1, which is negative 3, divided by the negative 3, the negative 4 plus 1, and this will be equal to the ln x, minus x raised to the power negative 2 plus 1, which is equal negative 1, divided by negative 2 plus 1, which is equal negative 1, plus the constant c. We simplify further, and we have negative 2. We move that y to the power negative 1 from the numerator to the denominator. Its exponent will change sign to positive 1. That negative divided by that negative will be positive. We move that y to the power negative 3 from the numerator to the denominator. Its exponent will change sign to positive 3. So we'll have 1 divided by 3 multiplied by y to the power 3, and this will be equal the ln x, and that negative divided by that negative will be positive. We also move that x to the power negative 1 from the numerator to the denominator. Its exponent will change sign to positive 1, from negative 1 to positive 1, plus our constant c, and this will be our answer. Question 6.2, we are to determine the particular solution of this second order differential equation, and I have shaded in yellow the initial conditions which we will use to determine the particular solution. So we have the d squared y divided by the dx squared we move the negative 9x from the left to the right, it will change sign to positive 9x. We move the negative 12 sin 3x from the left to the right, it will change sign to positive 12 sin 3x. From here, we are going to introduce the integral with respect to x, both sides of the equation. So we introduce the integral with respect to x on the left. What do you do on the left, you also do on the right. Even on the right, we introduce the integral with respect to x. On the left hand side, we have the integral of the second derivative of x with respect to x. The integral of the second derivative will be equal to the first derivative. So on the left, we have the first derivative of y, the dy, divided by the dx. And on the right hand side, the integral of 9x will be 9 multiplied by x. We add 1 to the exponent of the x. You already had that 1. So we add 1 to the exponent of the x. We divide through by the new exponent, the 1 plus 1 plus 12 multiplied by the integral of sin 3x. The integral of sin 3x will be a negative cos 3x. Remember, when we were differentiating, we were multiplying by the derivative of the 3x. The derivative of the 3x is 3. We are integrating, so we divide by the 3 plus the constant c. Let's simplify. We have dy divided by the dx equal 9 multiplied by x raised to the power 1 plus 1, which is 2, divided by 1 plus 1, which is 2, plus, also that positive multiplied by negative will be negative, and the 12 divided by that 3 will be 4. So you have 4 multiplied by the cos 3x plus c. So we were told to determine the particular solution. They wanted the value of that c, the numerical value of the c, and we are given those initial conditions. The initial conditions state that when x is equals to 0, y is equals to 1, and the dy divided by dx is equals to 2. So we have the dy divided by the dx is equals to 2, and when x is 0, y is 1. So we substitute. So in the place of that dy divided by dx, we are going to substitute the 2, and in the place of the x, we substitute 0. In the place of the dy over dx, we substitute the 2, and in the place of the x, we are going to substitute the 0. We have 2 is equal 9. In the place of the x, we have 0 squared. We divide through by 2 minus 4 multiplied by the cos of 3 multiplied by 0 plus c. 2 will be equal, so 0 squared multiplied by 9 divided by 2 will be 0. We have the negative 4 multiplied by the cos of 3 multiplied by 0, which is just 1, plus c. 2 plus 4 will be equals to c, and c will be equals to 6. We call it the particular solution because we have to determine the numerical value of these constants. So we determine the first constant as equals to 6. So now we have to find the y. We are going to introduce the integral with respect to x, both sides of the equation. On the left hand side, the integral of the first derivative is equal to the original function y, and this will be equal 9 over 2 multiplied by the integral of x squared. The integral of x squared is x squared. We add 1 to the exponent of the x. We divide through by the new exponent, the 2 plus 1, minus 4 multiplied by the integral of cos 3x. which is equal the sine 3x. When we were differentiating, we will multiply by the derivative of that inner function, the 3x. We are integrating. The derivative of the 3x is 3, so we divide by that. We divide by the 3 plus the integral of 6, which is equal 6x, plus our new constant, we can call it constant 2. We can simplify, so we have y is equal 9 divided by 2 multiplied by x raised to the power 2 plus 1, which is 3, divided by 2 plus 1, which is 3, minus 4, multiplied by the sine of 3x divided by 3 plus 6x plus c2. So we have to determine the value of the c2, but before that, the 9 divided by 3 is equal to 3, so we can substitute the 3 there. Since we are dealing with particular solution, we have to determine the value of the c2, the numerical value of the c2, using those initial conditions which we were given. We have y is equal to 1 and x is equal to 0. So we are going to substitute when x is equal to 0, y is equal to 1. So in the place of the y, we are going to substitute the 1, and in the place of the x, we substitute the 0. So we have 3 divided by 2 multiplied by 0 to the power 3 minus 4 multiplied by the sine of 3 multiplied by 0 divided by 3 plus 6 multiplied by 0 plus the c2. Alright, so most of the terms here will cancel out because they will be multiplied by 0. So that will cancel, and that will also cancel out, such that the numerical value of c2 will be equal 1. So in the place of the c2, we go right ahead and substitute the 1. And this will be our answer for the last question. Friends, thank you for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.